So the functions of assembler, it will be like translating to machine equivalent, assigning addresses to the symbols. So assigning addresses and translation can be done using two passes, Pass1 and Pass2, in which the Pass1 helps in defining the symbols and store those symbols into a data structure called SymTab, and Pass2 it helps in translating the opcode value to its machine equivalent. Also it helps in generating the data values that is defined by byte, word, etc. And it also helps in performing the processing of directives that is not done during Pass1. In Pass2, the forward reference also will be done in Pass2. And finally, the object program and assembly listing can be done in Pass2. So in order to perform all these operations, it makes use of some data structures like OpTab, SymTab, LOC, CTR. So LOC, CTR, it is used to store the location counter value, that is the addresses for each instruction. SymTab, symbols and its addresses. Symbols can be the labels also. Some labels will be acting as operands, so the label value and its corresponding addresses will be stored in the SymTab. OpTab will be like the operation code table, in which it checks whether the code that is being encountered it is of a valid one or not. OpTab. Its a machine equivalent also can be stored together with this OpTab table, operation code table. So an input program will be fed to an assembler. Assembler will be making use of these data structures to perform the Pass1 and Pass2 operations, so that it generates an intermediate code. So here an intermediate file is there, which is a file obtained after performing the Pass1 operation. What was the file? That is, it will be having addresses for every instructions. And then Pass2 only you will be generating the object code. First, address for every instruction will be generated based on the location counter value, and also using the SymTab, these addresses will be stored on for the labels that is being used in the program. So intermediate file, it includes each source statement, assign address, and if there is any error, that errors also will be indicated. The operation table, it will be having mnemonic operation codes together with its machine equivalent. It contains the instruction format and the length. LOC-CTR is equal to LOC-CTR plus instruction length. Then implementation is like it is a static table. It can be used as an array or hash table. Usually a hash table will be used for mnemonic opcode as a key. Then location counter initialization will be based on the directive start. Then location counter will be updated as location counter plus instruction length. And current value of location counter, it gives the address to the label that is encountered. SymTab consists of the label name, label address, type, length, flag. It helps in indicating the error condition also. It is a dynamic table. It helps in inserting, deleting and searching for any symbols that is used in the program. Usually it uses a hash table. hash function should perform non-random key. For example, loop 1, loop 2, XYZ. So next we are coming to the algorithm part, where how this data structure can be used in order to translate the input to its machine equivalent. So Pass1, two algorithms are there, Pass1 and Pass2. So in case of Pass1, it begins with checking whether the opcode is equal to start. If the opcode is equal to start, the operand will be start, one address will be given. That address is the operand field. That address will be saved as the starting address. So LOCCTR will be assigned to that address. Write that line to the intermediate file. So what will be the intermediate file will be like? It will be having some write line to the intermediate file, that is, it will be having copy start and pause it. It will be written on the intermediate file. Okay, and then read the next input line. So what was the next input line? If you check your textbook, you can see the next input line is first STL writ address. So 1000 will be assigned to that line. So 1000 first STL writ address. So first 1000 STL writ address. Then each instruction is of 3 bytes. So it is incremented by 3. Like that it goes on. Changes occur when here the changes will be occurring. Like reserve byte 4096. So the next address will be like 1039 plus 4096 bytes it should take. Here also 3 bytes, here 3 bytes. One word is equal to 3 bytes. Here 3 also 3 bytes. Here also EOF, it is length is 3, so 3 bytes. If it is like first, like that some other string of length 5 is there, means there are also some differences there. That is, the length of the string will be taken. If I instead of EOF have given like end of file, like END OF FILE, if I give like that, means the length of that particular string will be taken and it should be added with this location counter value. So 1028 plus the length of the string that is given, if it is byte. Word means what is the constant value that is given, that will be stored to this variable, but the number of space will be like one word is equal to 3 bytes. So 2D plus 3. Again here also the same. The serve word, here one it is given, so one word is equal to 3 bytes. So 1033 plus 3, which is 1036. If it is like the reserve word, if instead of 1, if it is given like 2, means 2 into 3, which is equal to 6. So 1033 plus 6 it need to take. So that is the calculation regarding the location counter. So first, if it is equal to start, assign the starting address to the location counter. Else, if no address is given, initialize the location counter to 0. And check opcode whether it is equal to end. If it is equal to end, means it reached to the end of the program. If it is not equal to end, means some processing needs to be done. What all are the processing that is done? Checks whether it is a command line. If it is not a command line, it checks whether the symbol in the label, whether there is any symbol in the label field. So the program is label field is where opcode operand. So if it is if there is any symbol in the label field, then you need to check for the symbol in the sim tab. If any label is there, that label need to be checked. If symbol table label is there, means set error flag because it indicates a duplicate symbol. So label field, if a new symbol is being encountered, then insert that label to the sim tab with the address, label and its location counter value. Then again search the op tab for the opcode. Label, if it is found, means display error. If it is not found, insert it into symbol table. Then search op tab for the opcode. If it is there is no label, it searches for the opcode in the operation table. If found, means length will be, each instruction is of 3 bytes. So add 3 to the LOC CTR. Okay. So if any instruction it comes, means you need to add 3 to the LOC CTR if the opcode is valid. And if the opcode is word, RESW, RESB, bytes, they all belong to the assembler directives. So if this assembler directives is being encountered, so instruction length will be updated according to the directives. Word means add 3. Reserve word means add 3 into the operand value. Then reserve byte means add the operand value to the LOC CTR. If it is byte, means you need to find the length of the byte and then add the length to the LOC CTR. So these are the things that need to be done while allocating the space or addresses to the labels and instructions. So all these conditions, if it is met, then write the line to the intermediate file. So intermediate file will be having an address, it will be having the label, then opcode, operand. Again it reads the next input line and it continues until it reaches to the the end of the directive, that is end. If it reaches end, what it does, it exits from this loop and write the last line to the intermediate file. So what is the last line? The end. End is the last line, in which after writing the last line and its address, last line and an address also will be written. So save LOC CTR minus starting address as the program length. So length of the program will be like LOC CTR minus starting address. Starting address will be there in the first instruction. LOC CTR will be the current instruction that is being executed. Difference if you take means you will be getting the length of the program. Okay, so till the end of the program, the process will continue. Once the end directive is encountered, it exits from the loop and writes the line to the intermediate file. So a line will be like end and the starting address of the program. Starting address of the program. It will be either the name of the program or the any label that is assigned to the starting address.